in this session, we want to talk about slope and the rate of change. So slope, let me use super black. So the slope and the rate of change. So let's look at what rate of change is all about. So for two or more quantities that are related, when we talk about rate of change, better still if we limit ourselves to two items or quantities that are related. The rate of change is just an expression of how much one quantity changes with respect to the other. So let me put it this way, that the rate of change, this expresses how a quantity changes in relation to another quantity. Now this change, normally we can find, this change can be found this on tables. You can find this on graphs. And through equations. And this change mostly will occur over time. Okay. So that is what we call the rate of change. You're looking at how much one quantity that is related to another quantity changes, and in a way, how much the other quantity is also induced to change. Okay. So let's look at a very simple example here. Table shows distance traveled by a car in a day. So let's get a table here. So let's say table, something like that. And still 1, 2, 3, perfect. So this is the distance. The distance is going to be in miles. This is the time. time here is in minutes. So I have 45, 90, 135, 180, and 225. Now with the time, I have 35, 70, 105, 140, and 175. Okay. So the question is, use the table to determine the approximate rate of change. Miles per minute. All right. Let's look at how to go about this situation. Now, from the table, you can see something clearly here. We see that for every 35 minutes drive, there's an increase of 45 miles that the vehicle, adds on its mileage, if you will. So let me put it this way. From the table, for every 35 minutes drive, the distance traveled, increases by 45 miles. So this tells us the rate. Okay, so the rate will be nothing more than, what's the rate of change? Nothing more than, by the question, it says miles per minute. So miles is in terms of distance. So the change in the distance traveled divided by the change in time. Okay, just simply so. Okay, and we'll realize that this is 45 miles, and that is 35 minutes. And so if we should simplify, 5 goes into 45 9 times, goes into 35 7, and that will give us miles per minute. That will be our answer. So this is how, when we talk about rate of change, this is what happens. We are always looking at a change in one quantity with respect to a change in the other quantity. In other words, these two quantities or more quantities should be related of some sort. Now let's look at the slope as a rate of change. slope as the rate of change. Now we're dealing with linear equations, and so one of the main characteristics of a line or a linear equation is its slope. The slope normally tells you how steep or how slant the graph of the line is or will be. Okay, so that is the most important characteristic of a line, if you will. The slope is always very, very important. So let's put it this way. The slope tells how steep or slant, equation of a line is. As a matter of fact, every line that you have is made up of infinitely many points, many ordered pairs. And so the fact is, if you're able to identify 2 points on the line, basically the line through these points, you should be able to get the slope of this line. So basically slope is the rate of change. That's slope is the rate of change between any 2 points on a given line. Let's consider a graph of a given line, okay? So let's say that this is my graph here. Okay, and this is your y, this is my x, and let's say that this is my line, somewhere there is the line, and I'm assuming that there's these 2 points on the line. Let me take it from here and somewhat there. Okay. Remember that every point on the coordinate system has 2 coordinates, if you will, has 2 numbers there. And we have the x and the y. This is what we call the ordered pair. Okay, so every point has to have an x value and a y value. For this point, I assume that the x value is x1, and then the y value is y1. For this point also, I'm going to assume that the x value is x2 and the y value is y2. Now, in that case, I should be able to find the differences between the x's and the y, or the absolute difference between them. So here, I'm talking about this difference here and this difference here. It's going to be y2 minus y1. This difference here is going to be x2 minus x1. Okay. from here, we should be able to establish our slope of the non-vertical line, the red line there. We should be able to find that. So the slope of the non-vertical line above is basically the rate of change of the y with respect to the change and normally in this class we're going to use m for slope. So the slope will be m, and this is going to be what we call the vertical change over the horizontal change. Or simply the change in y or the change in x, which of course we also know as the rise by the run. Okay, so if you look at the sketch here, the change in y is y2 minus y1. The change in x is x2 minus x1. And we can plug these here, and that will give me y2 minus y1 over x2 minus x1. And this is the slope. This is the slope formula here. The slope formula here. And here x2 should now be equal to x1. So otherwise it will be undefined. Okay, so this is the slope formula. So if you are finding the slope of a line that goes through 2 points, assume that one point is x1, y1, and the other point is x2, y2. And note that the slope formula is y2 minus y1 over x2 minus x1. You plug your value is in there and be able to calculate, whatever you get there is going to be the slope of this line. So let's do a couple of examples here. Find the slope of the line through the given points. (6, -8) and -2, 4. Let's go through this first off. Let's see. So the points here are 6, -8, -4, 4. I mean -2, 4. I'm going to assume that this is my x1, this is my y1. I'm going to assume that this is my x2, and that is my y2. Based on the formula, the slope m is y2 minus y1 over x2 minus x1. If I plug my numbers in there. It's just going to be 4 minus -8 divided by -2 minus 6. Remember that 2 negatives will always be a plus. This is not the case. This is -2 minus 6. -2 minus 6. -2 means you own 2 items. -6 means you own another 6 items. So together, how many items are you owing? It's going to be 8. And when your owing is always negative. That gives you 12 over -8. You should be able to simplify. 4 goes into 12 3 times. It goes into -8, -2. Now, this is what you have. But note that because it's a fraction, this negative is not only affecting the 2, it's affecting the whole fraction. So it will be good for you to put the negative in the middle, like that, and that will be your slope. Do another one with a fraction. Find the slope of the line through the points half minus 1/3 1/4, 1/5. So the same idea, how these points here. This is going to be my x1, that will be my y1, x2, and my y2. I'll go to the next page to work on that. Let's go to the next page. So the slope is y2 minus y1 over x2 minus x1. We already know what our x2, x1, y2, y1 are. So I'm just going to fix them there. Y2 is 1/5 minus y1 is -1/3 divided by x2 is 1/4 minus x1 is 1/2. So something like that. I'm going to try to simplify the numerator separately and do the same for the denominator. And then finally, I'm going to divide my 2 results. Okay, so I'm going to have 1/5 plus 1/3. Remember, I have 2 negatives. So that will be a plus. Then divided by the denominator, which is basically that. You can always rewrite it like this. With a fraction, I need to get LCD. With this one here, the denominators are 5 and 3. So that tells me that the LCD is going to be 15. I need to get 15 for 5 and 3. Over here, the denominators will be 2 and 4. And so 4 is going to be the LCD. So let me use red to denote all of that. use red to denote all of those very soon. So I need to change 5 to 15, so that'll be 3 here and 3 there. The 3 to 15, so that'll be 5 here and 5 there. I need to change the 2 to 4. The LCD is 4, so 2 here and 2 there. I don't need to change this because the LCD is already 4. And so once I do that, I'm going to be left with 3. 1 by 3 is 3. 5 by 3 is 15. And plus 5 over 15 divided by, over here is going to be 1/4 minus 2 over 4. And once the denominators are the same, I keep same denominators, so 15, and then I sum up the numerators, right? Same here, I keep the 4, and then I subtract the numerators. Once I do that, that gives me 8 over 15 divided by, this is -1 over 4. Remember that if you're dividing, you change to multiplication, and then you flip the fraction on your right hand side. So 8 over 15 times 4 over -1. From here, I don't see anything canceling. This is not reducible. So I'm just going to multiply across 4 by 8, 8 by 4, and then 15 by -1. And that should give me 32 over -15. And again, mind you, the negative is not only affecting the denominator, it's affecting both. So I can push the negative in the middle, and that will be my slope. All right. I hope this helps you out. Okay. So we said that one unique characteristic of any line, any linear equation, or any line, if you will, is its slope. Now, what the slope does is that apart from telling us how steep or how slant the line is, it also tells us the direction of the line. So we want to look at the direction of lines by slope. Let's look at that. Direction of lines by the slope. So the slope tells us the direction of a given line from left to right. Okay. Basically, it tells you slantness. Is it positive slant or negative slant, or is it horizontal, or is it vertical? So that is what we want to look at. 4 cases here. First one, If the slope is positive, if the slope is positive, remember we use m for slope, that is m is greater than 0. Okay, that means it's positive. Then the line rises from left to right. Or basically, the line moves from left to right upwards. And this is what you see if you want to look at the sketch. This is just a very simple sketch I'm doing here. X, this is Y. Let me get this line here. Okay. So this is where we have a positive slope. So positive slope. Positive slope. Okay. Then we have the second one. Slope of the line is negative. That is if m is strictly less than 0. Then we have a non-vertical line that falls from left to right. In other words, there's a decrease from left to right. Let's look at a sketch of it. Something like that. So a case in point is something like this, right? My x, this is my y, this is the line. This is why you get a negative slope. Then we have the third one. If the slope is 0, right? That is m equals 0. Then the line is horizontal. And every or any horizontal line moves infinitely from the left to the right, as if you are on the number line. Okay, so a sketch basically will be like this. Right? And say this is just a line. Simple like that. This is my y, this is my x. So this line has a slope 0. So it's always going to be a horizontal line. Okay. And finally, we have the fourth one. If the slope is undefined, and when we say undefined, that is the denominator goes to 0. You get undefined. Your calculator will say error. Okay. If that is the case, then the line is vertical. Vertical. So let's put it on that form. Let's look at this graph here. And this is my y, and this is my x, and a vertical line, basically something like that. Okay, so there's a vertical line, and the slope here we call undefined. When you use the formula, slope formula, and you realize that your denominator value is 0, that should tell you that you have a vertical line because your answer is undefined. Let's look at some examples. Find the slope of the line through the following points. Through the following points. And determine the direction of the line. A here, 2,5, and -1,5, and B 3,1, and 3,-4. So as usual, use a slope formula. Slope m is y2 minus y1 by x2 minus x1. Okay. So in the first case, I have my points as 2,5 and -1,5. So that would be my x1, y1, x2, y2. And if I plug these back here, I should get my y2 is 5 minus y1 is 5 divided by x2 is -1 minus x1 is 2. So this is just going to give me 0 over -3, and 0 over any number is 0. So the slope is going to be 0. So look at it carefully. And if the slope is 0 from the direction thing that we did up there, you realize that then this line is a horizontal line. Okay, so we have a horizontal line. Horizontal line. Let's look at the B. The points 3, 1, and 3, -4. Same here, I'm going to do x1, y1, x2, y2, and then the slope and is y2 minus y1 over x2 minus x1, and y2 is -4 minus y1 is 1, x2 is 3 minus x1 is 3, so that will give me -5 over 0. So remember what I said before, if the denominator is 0, this cannot be found. Your calculator will say error, so this is what we call undefined. Undefined. And because the slope is undefined, what it means is that therefore the line through the points is vertical. Vertical. Okay. So this is how we are able to determine the nature of a line, whether it's a positive slope, a negative slope, a 0 slope, undefined slope, and what it tells us of the nature of the line, whether it is horizontal, whether it's vertical, or whether it is rising from left to right, or falling down from left to right. Okay. How you get to do it. So let's look at this application problem here. We're looking at the population of Springfield, Massachusetts. This is the data for population. In 2010, the population was 153,060. And then just last year, the census data revealed that the population size increased to 155,929. So this is Springfield, Massachusetts. The question is, what is the rate of change of the population per year? So we are looking at a 10-year gap here from 2010 to 2020. Okay, so this is purely a rate of change problem. This is purely a slope problem, if you will. And so let's do it this way. So we need to have 2 points. Of course, the points have been given here. The points will be the population data and then the year. Okay, so in 2010 it was 153,060, and then in 2020 it was basically 159, and 155,929. So we can form another pair easily here. For the first one, 2010 we're going to have 153, 60, and then 2010. And in the 2020, we have 155, 929, 2020. Okay, so we want to find the average of change of the population per year. Okay, the rate of change will just be the change in population size divided by the change in time or year. So change is just going to be 155, 929 minus 153, 60 divided by 2020 minus 2010. Okay, so you can just grab your calculator, do that. Let me grab my calculator quickly here. So I have 155,929 minus 153,060. That gives me 2869. And of course, 2020 minus 2010 is just 10. So when you divide, just move the decimal point one place to the left. That should give you 286. So that will be the average rate or rate of change. So what it means that the population increases every year by this number of people, almost 87 people, okay, for every year. Okay. So let's put it this way: the population Springfield changed by 287 people per year. Okay, so this is basically an application, and it's all about, it's just about using the slope formula here. Okay, so we've talked about, so far we talked about the table form, we talked about the graph form, which in this case gives us the slope formula, and we should be able to get a slope out of a given equation. So let's look at that quickly, finding the slope of a line from its equation. Finding the slope of a line from its equation. remember that we said that the equation of a line is of this form. The equation of a line of the form ax plus by equals c, and where a, b, and c are some real numbers. Some real numbers. Okay. For instance, if you have 3x minus 4y equal 10, that's a typical example. Now, this form is what we call the standard form. This form is known as the standard form. So remember that you only have a standard form where both variables are on one side of the equation. So like in this case, we have ax plus by. You see the x and the y on the left side of the equation. So once we have both variables on one side, either the left or the right, then we do have what we call a standard form of the equation of a line. So how do we find the slope of a given line that is in standard form? Look at the steps. So first, solve. So given ax plus by equals c, solve for y. Okay. And then 2, once you solve for y, then the slope is basically the coefficient of the x term. Okay, so note that you got to first solve for y. Once you solve for y, you then have to take the value in front of your x, and that represents your slope. So do not just pick the coefficient of x right from the beginning and say, okay, this is the slope. No, first solve for y. I'm going to do a demonstration here. Okay, so let's do a demo. Right, so I have ax plus by equals c. If I'm going to solve for this y, anything that adds or subtracts has to go out. So I'm going to subtract ax here, subtract ax here. Okay, and that will be left with by, because then the ax will cross out. Then I'm going to have minus ax plus c. The c here is positive. That's why we have the plus there. And then I got to divide both sides by b. So divide by b. Okay. So if I do that, it means by over b, ax over b, c over b. Okay. The b is going to cross out, so we'll be left with y equal negative a over b x plus c over b. And in this case, once I get here, then what it means that the slope, which we use m, is going to be the value in front of the x, the coefficient of x, which in this case is going to be negative a over b. Will be a slope. So for instance, if I have this example here, find the slope of the given line. Two x minus 3y equal 4, right? Remember that this is in standard form. And if I do comparison, look at it carefully. If I compare with ax plus by equals c, right? It's very, very easy when you do it this way. If I compare with this is the x, this is the x. So that tells me that the a value there is 2. If I compare y with y, then it means that the b value is -3. And then this is the equal to, that tells me that what is on the right side of the equation, c, is what? 4. Okay. So based on what based on the demo, if you go through it, you see that the slope is nothing more than what? Your -a over b. Okay. So the slope is -a over b. And a is what? 2. So 2. Beta is what? -3. And remember that 2 negatives will always be a plus. So that will turn out to be what? 2 over 3. That is going to be a slope. So this is one way you could do it. If you remember how to do comparison here. Okay. You write down the given equation, and then you try to compare with the standard form of any linear equation. Once you get your a and your b, just that. Remember that the slope is -a over b. Plug those there and you get your slope. If you can't remember, then alternatively, let's go to the next page. And alternatively, I have my 2x minus 3y equal 4, right? So what I'm going to do is I'm just going to solve for y. I need 2x to go away. So minus 2x here, minus 2x here. 2x will cross out. So I'll be left with -3y. And then if I rewrite this, it's just going to be -2x plus 4. And from here, I divide both sides by -3. So divide by -3. So means that -3y over -3, -2x over -3 plus 4 over -3. The -3 here is crossing out, so I'm just going to be left with my y. Remember, 2 negatives will always be a positive, so they cross out. So I should be left with 2 over 3x, and then a positive and a negative as you divide is going to be a negative. So that'll be 4 over 3. So this is where I get to. And from here, what it means that the value in front of the x is going to be your slope. So therefore, slope is 2 over 3. You are done. Let's do another one. find the slope of the given line. (3x minus 5y equal -1). So I'm going to do this in two ways. So I have my 3x minus 5y equal -1. And I'm going to compare with the general standard form of an equation. So look at it carefully. This is ax, and this is 3x. The x here is the same as the x there. That should tell me that my a is 3. This y here is the same y here. That should tell me that my b is -5. And then my c, which I really don't need it, is going to be -1. And from here, I know that the slope is -a over b. Okay, so I just plug my values in there. -3, a is 3, b is -5. Again, two negatives will cross out, so that'll give me 3 over 5, and that's going to be my slope. If you don't want this, then the alternative is my 3x minus 5y minus 5y minus 5y equal -1. What I'm going to do is I'm going to try to solve for y. Anything that adds to it or subtracts from it has to go away. I have 3 adding to it, so I'm going to subtract 3x from both sides. The 3x will cross out. I'll be left with -5y equal. If I rewrite this, I'm going to bring the x first, so -3x minus 1. And then from here, I divide through by -5. Okay, so it's going to be -5y over -5, -3x over -5, -1 over -5. The -5 is going to cross out, so I'm just going to be left with y. 2 negatives will always cross out, so I'm just going to be left with +3 over 5x. 2 negative will cross out, and that will become a positive, so +1 over 5. So once I get here, I have to understand that the value in front of the x now becomes my slope. Therefore, slope m is 3 over 5. Let me give you one to try. Find the slope of the line. 3x plus 2y equal 9. You can pause this video and work through it, but the answer will be the slope. You should get -3 or 2. So pause the video and try it your hands on. And I want to believe that this will be helpful for you to go through your homework assignment. Thanks for watching.